So this is question 1. Find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus 8x to the half. The important things I have in this question is that I'm looking for the first 4 terms and I want the binomial expansion. So I know that the binomial expansion formula is on my formula sheet, so I'm going to look at that, and from that I know the formula, so I'm just going to write that down. That's for 1 plus x to the power of n is equal to 1 plus n x plus n minus 1 over 1 times 2 times by x squared plus n minus 1 n minus 2 over 1 times 2 times 3 times x cubed plus dot dot dot. So I'm not going to write any more because I only want the first 4 terms. So 1 plus x to the n is similar but a bit different to 1 plus 8x to the half. So I know that I need to have n as a half, and instead of x, I'm going to use 8x. So what I'm going to do is substitute this into my formula. So I've got 1, n is a half, instead of x, I've got 8x, n is a half minus 1, over 1 times 2, and instead of x, I've got 8x all squared, plus a half minus 1, a half minus 2, all over 1 times 2 times 3, and then I've got 8x all cubed, plus what comes next. So let's simplify this a bit. So I've got 1, a half times 8 is 4, and I've got a half times a half minus 1, which is minus a half. 1 times 2 gives me 2. I've got 8x squared plus a half minus 1 minus a half minus 2 is minus 3 over 2, and that's over 1 times 2 times 3, and I've got 8x cubed plus, simplifying again, so 1 plus 4x stays the same, and then I've got a half times minus a half divided by 2 times by 8 squared. So I can use my calculator to help me with this. So I've got a half times minus a half over 2 times by 8 squared, which is minus 8. So I've got minus 8 and then x squared. So let's do the other one. So this time I've got a half times minus a half times minus 3 over 2. Minus 3 over 2 over, well, 1 times 2 times 3 doesn't simplify before, but that just makes 6. And I've got that times by 8 cubed. Sorry, this bracket should be here. So it's 8x cubed, which gives me 32. So I've got plus 32, and that's an x cubed. And so on. So I've got 1, 2, 3, 4 terms. I did the binomial expansion. So that's question 1, part A. A. So now let's have a look at B. So that one says, explain how you could use x equals 1 over 32 in the expansion to find an approximation for the square root of 5. And there is no need to carry out the calculation. Cool. So first thing I'm going to do is I've got x equals 1 over 32. I'm going to substitute it in to 1 plus 8x to the half to see what I get. So if I sub that in, I've got 1 plus 8 times 1 over 32 all to the power of a half. So let's figure that out. So that's 1 plus 8 times 1 over 32 gives me 5 over 4. So I've got 5 over 4 all to the power of a half, which gives me root 5 over root 4, and simplifying that is root 5 over 2. So I want an approximation for root 5. So that's not quite what we want, but we're almost there. So from the first question, I know that 1 plus 8x to the power of a half, 1 plus 8x to the power of a half is equal to this when it's expanded out. So if I sub in 1 over 32 into this bit, and I get root 5 over 2, that means if I substitute 1 over 32 into this bit too, I'm also going to get root 5 over 2. So let's write that down. So substitute, I think I spelled that wrong. Substitute, there we go, 1 over 32 into 1 plus 4x minus 8x squared plus 32x cubed. That's going to give me an approximation for root 5 over 2. So this gives me an approximation for root 5 over 2. So then to get an approximation for just root 5, all I need to do is multiply by 2. So what I did is I substituted 1 over 32 into the expansion, and then I multiply it by 2. And that gives me an approximation for the square root of 5.